First, let's recap the interactions between positive and negative charges. When a positive is placed next to a positive, they tend to repel. The same applies with a negative-negative interaction. Both charges will try to repel each other in the opposite directions. Although when you have a positive and place a negative next to it, two of the opposite charges would attract. So first off is the ion-dipole interaction, a reaction between ionic compound and polar substance. An example of this would be table salt, which is sodium chloride. Wherein sodium is metallic and chloride is non-metallic, sodium is a positively charged ion, therefore is a cation. Chloride is a negatively charged ion, therefore it's known as an anion. With all this in mind, this is what qualifies two ions as an ionic compound. So what then is a polar compound? So this happens when the electrons between the two atoms are only partially negative and positive. An example of this would be water, also known as H2O. So using the Lewis structure of water, both atoms are sharing electrons, which makes this a covalent bond. But here's the thing, oxygen has 8 protons and hydrogen with only 1, making this oxygen attract hydrogen much stronger than hydrogen's ability. This is known as electronegativity. As a result, the oxygen side is slightly negative and the hydrogens become slightly positive. The positive and negative ends create poles, sort of like a magnet. So to summarize, polar covalent compound shares electrons unequally and thus create dipole, which cause intermolecular attraction, which is the attraction between the atoms. Now the terms are out of the way, now for the reaction. So when you combine an ionic compound to polar substance, the cation, the positive charge of the ionic compound, would be attracted to the opposite charge of the slight negative pole of the polar substance. Same with the anion, negative attracted to the positive pole. And this is how it would look like if the compound had both cation and anion. Here's an example of ion-dipole interaction. Salt dissolves so well in water because the covalent bonds of water are stronger than the ionic bonds in the salt molecules. Reaction as a result, the water molecules pull the sodium and chlorine ions apart, so they are floating freely. These ions are what carry electricity through water with an electric current. Last thing to note is that sodium chloride and dihydrogen monoxide in the illustration are the inter for intermolecular bonds, and the bond between the sodium chloride and dihydrogen monoxide is intra for intramolecular bonds. And intermolecular bonds will always be stronger than intramolecular bonds. Second is the dipole-dipole interaction, which occurs between two polar substances. Taking hydrogen chloride as an example because of the uneven distribution of electrons, with hydrogen's electronegativity of 2.1 and chloride with 3.0, making hydrogen a slight positive and chloride a slight negative. So if you were to combine it with another hydrogen chloride, there would be an attraction with delta negative chloride with delta positive hydrogen of the other. Number 3. Hydrogen bond. Hydrogen bonding are strong intermolecular forces created when a hydrogen atom is bonded to an electronegative atom. Greater electronegativity of the hydrogen bond acceptor, particularly the second row of elements, nitrogen, oxygen, or fluorine, the hydrogen bond will lead to an increase in hydrogen bond strength. The intermolecular forces present in a sample of water are hydrogen bonds. The high surface tension of water allows a paperclip, to float on the surface of the water. It's not actually floating, it's resting on top of the hydrogen bonds that exist between the water molecules at the surface. If the hydrogen bonds are removed or disrupted, the surface tension will decrease. Number 4. Dispersion forces. Dispersion forces is a result of combining a polar substance with nonpolar substance. A new term, nonpolar substance. So if a polar substance is an unequal share of electrons, nonpolar is when electronegativity is equal sharing of the bonding electron pair. An example is the mixture of water and palm oil. Water as our polar covalent compound and oil as our nonpolar covalent compound. The oil does not dissolve in the water because the nonpolar only likes other nonpolar substances, and polar only mixes with other polar substances and reacts with ionic. The intermolecular forces that operate between the particles in a nonpolar compound is too weak to interact with the water, so they stay separate from each other, dispersed, thus the name dispersion forces.